Hey everybody, welcome to another remote lesson for remote learning. Today we're going to be talking about section 9.3 out of the book titled Exponents, Products, and Powers. Oh my! So we're going to be discussing three properties that have to do with powers and exponents. Remember that a power is made up of its base and its exponent. And collectively, all together, this whole thing, okay, is called a power. So once again, we're going to talk about three properties that have to do with powers and exponents. The first one we're talking about is called a product of powers, which states that if you multiply powers with a common base, then you may add the exponents and keep the same base. And that is described algebraically here. If we have x to the power of a times x to the power of b, what we have are common bases, which allows us to add those exponents. So in practice, okay, here we have x to the power of 8 times x to the power of 20. Remember, because the parentheses are up against each other, it's implied that's multiplication. And if it's easier to see, right, well, this is, another way to write or express the same thing. So we have a common base. We are multiplying these powers together. And so if we're asked to simplify, we're able to add these exponents together to get 28. And that's it for that, okay? Powers with a common base, add the exponents, keep the base the same. X to the power of 28 is our answer. Now, if we had something that had a little bit more going on, here we're multiplying 3 times x to the 7th and 5 times x to the 5th. So with the exception of those exponents, what we have here is a string of multiplication. So what I like to do is I like to remove the parentheses, all right, and seeing that we're multiplying those things together, and even take it one more step further and regroup common factors, looking like that. All right, so don't forget, we know how to do 3 times 5, nothing fancy going on there. It's just 3 times 5. And then over here on the right, we have x to the 7th multiplied by x to the 4th. Those, we have a common base, and so we're going to add those exponents. And that's going to give us x to the power, of course, of 11. And that's it. That's our answer fully simplified. Okay? Moving on to the next property, we have what's called a power of a power. If you raise a power to another power, then you're going to multiply the exponents. So here we had x to the power of a, and that whole thing being raised to the power of b. As you can see, we're just multiplying the exponents together. So here on the first example for this property, we have y to the 5th being raised to the power of 3. And since that is a power to a power, we are going to multiply those two exponents and get y to the 15th. On the next example, we have two separate instances of powers being raised to powers. We have y to the 4th being raised to the power of 2, and we have y to the power of 6 being raised to y to the power of 3. Of course, 4 times 2 is 8, and of course 6 times 3 is equal to 18. But then what we have left over here is a power being multiplied to another power that has a common base. So we have a common base here, and if you multiply powers with a common base, you may add the exponents. And so what we have here as our final answer would be y to the power of 26. Moving on. The last property that we're going to talk about today is called a power of a product. And what this says is that exponentiation distributes over multiplication. And I've got to be really careful here that it distributes over multiplication. So here we have x times a in parentheses, or this quantity, being raised to the power of a. And so what it says is we are allowed to raise each base to that power. Sorry, getting in the way here. Okay, so it's another way to think about it. We're going to raise each base to that power that's on the outside. And I can't emphasize enough, it's only when we have multiplication. We'll talk about a counterexample in a second. Or not a counterexample, but a mistake you want to avoid. So here, this first problem, we're being asked to simplify x times y, in parentheses, being raised to the fifth power. And not too much going on here. We're just going to distribute the power of 5 to both the x and the y. And since they were just x and just y, we're just going to get x to the fifth and y to the fifth. Well, let's say we have a little bit more going on. Here, okay, we have x to the seventh and y, and we are raising each of those to the power of 3. Now, I chose to write it a little differently here because here we have x to the seventh. Now x to the seventh is getting raised to the third power. And so this is going to have us refer back to that previous one where we have a power of a power. And when we have a power raised to another power, we're going to multiply those exponents together, leaving us with x to the power of 21 times y to the third. We are going to just do two last examples where we kind of bring everything together, all right? So this first problem here, we have a series of multiplication, 3 times x to the sixth times y to the fourth, and that whole thing is being raised to the power of 4. So what I'm going to do is I'm going to take each base and I'm going to put it in parentheses. And each of those bases is being raised to the power of 4. 3 to the fourth is equal to 81, because that's 3 times 3 times 3 times 3. We then have x to the power of 24, because we multiplied those exponents. And then we have y to the power of 16, once again, because we have a power of a power, which means we're going to multiply those exponents together. Okay, for the last one, we're just kind of throwing everything in together here, everything into the mix. So we have these separate groups of parentheses that have their own individual powers. So what I'm going to do is what I did in the previous problem. I am going to put each base in parentheses, raise it to its individual power. And those are getting raised to the power of 2. All right, so notice the parentheses here. Okay, these have to be in parentheses. So we have -2 times -2 times -2 times -2. That's equal to 16. X to the fourth is just going to be x to the fourth. We now have 3 squared, or 3 times 3, which is 9. We then have x to the power of 6 and y to the power of 10, because these are powers being raised to powers, so we're multiplying the exponents. And then we're just going to take a moment and we're going to put this all together. Okay, so in previous examples, what you see here is I'm just regrouping everything so that the similar stuff is getting grouped with the similar stuff. You don't have to, but I think it's a good way to organize. We're going to do 16 multiplied by 9, which happens to be 144. X to the fourth times x to the sixth. We have a common base of x, and we're multiplying them, so we're going to add those exponents, giving us x to the 10th. And then that y to the 10th is staying y to the 10th because it had nothing to go with it. This video went a little long, so I do apologize for that. Please take your time with this stuff, and as always, if you have any questions while you're doing your homework, please feel free to reach out to me, as I always want to help. I hope everybody's doing well, and I hope to see you soon.